Sometimes we compute probabilities when we're given a set of data from a survey. So for example, here we've surveyed students and identified their color of their shirt, black, blue, yellow, or other. And each student has listed exactly one of these categories. So even if they had a shirt that was black and blue, they had to sort of identify. I'm going to call this shirt mostly black. So let's first begin by finding our total. Our total in this case is that these are all the students who answered my question. And when I add up the 10, 6, 2, and 6, I have that there are 24 total. So if I were to list out my outcomes, it would be 10 students wearing black shirts, 6 students wearing blue shirts, 2 students wearing yellow shirts, 6 students wearing other, out of a total of 24. So the probability of black would be 10 out of 24. And I can reduce that fraction by dividing both numbers by 2. The probability of not blue, I can find the numerator two different ways. One possibility is that I recognize that that would be black plus yellow plus other. Those are the ones that are not blue. In other words, 10 plus 2 plus 6. And that adds up to 18. The other possibility I could use is to say there's 24 total, 6 of them are blue, and so therefore all the rest are not blue. So I can now take my 18 divided by 24, and when I divide both of those by 6, I get 3/4. So the probability of black was 5/12. The probability of not blue was 3/4. If I want to find the probability of black or yellow, then I would say that's going to include everybody wearing a black shirt. It's also going to include anybody wearing a yellow shirt. And so that becomes 12 out of 24, which is 1/2. Now I can use percent chance or probability to answer questions. If I know the probability that an event occurs, I can predict the number of times it will happen in a given group by taking that probability and multiplying it with the total number in the group. So let's take a look and just refresh with that rolling a six-sided die example. If I roll a six-sided die, the probability I roll an odd number would be, out of the 6 possible outcomes, that would include 1, 2, 3 of my outcomes. So it would be 3, 6, or 1/2. If we want to write that as a fraction, that's fine. If we want to write that as a decimal, that's also fine. This is the probability. What is the percent chance that I roll an odd number would simply mean take that and convert it to a percent by multiplying by 100, just like we've been doing. And finally, if I roll the die 110 times, about how many times would I expect to roll an odd number? Now, I realize that you can just take half of 110, but I want you to look at it in the context of what I've written up here as well. Think about how if I take my probability times the number in my group, that is taking half of the 110. So that is giving me my 55. And it's not guaranteed. This is just giving me a ballpark. It's a ballpark estimate. And the idea here is that I'm pretty likely to get an odd number somewhere near 55 out of the 110 times. It could be 49, it could be 58. I'm not very likely to roll the die 110 times and get an odd number twice and an even number 108 times, because my probability numbers tell me that somewhere around 50% or half of them should be odd. Let's do that again for the next example. Suppose 31% of the employees at an organization are male. What is the probability that a randomly selected employee is female? Well, let's find the percent chance that an employee is female. There are 100% total at the company. If I take away the 31% that are male, then that leaves me with 69% that are female. And as a probability, I simply divide by 100 to get it as a decimal. And to use the probability notation here with you, you can write that as probability of female. If there are 600 employees at work today, approximately how many of them are male? Well, 0.31 is the probability of male, and 0.69 is the probability of female. And in either case, I can use this multiplying probability times the number in the group to find approximately how many I can expect to be in each category. So if I multiply 0.31 times 600, I get approximately 186 males. And if I multiply it by 600, then I get approximately 414 females. Now, at this point, I usually have groups break apart or break out from the class and work on these 11 problems in the book. They reinforce what we've done here so far and just give you a chance to practice it yourself.